right, this is just a practice page on anti-differentiation by guess and check. So I would suggest that you go ahead and try all these problems, and you can check the answers just on the hard copy that we put in the answer key, or you can listen to me talk you through it, or you can just fast forward to the ones that you had trouble on. So let's get started. For number 1, you know that sine is going to anti-differentiate to negative cosine, and because we have this constant, well, we have an inside function whose derivative is a constant, so we're going to have to divide by that constant. Remember, when you differentiate with the chain rule, you multiply by the constant 3, so when you anti-differentiate, you'll divide by the constant 3. All right, cosine integrates to sine. On this one, your inside function is 2 minus 5x, and the derivative is a negative 5, so you're going to have to divide by the negative 5. And by the way, all of these, you're finding the general antiderivative, so you're going to need a plus c on every single one of these. Also, none of these have like an f of x equals, so you don't need an equation here. These are just expressions, so when you integrate, you just have expressions. All right, this is 1 over the square root of 8 minus x, which is the same thing as 8 minus x to the negative 1/2. When you go up a degree to 1/2 and you divide by 1/2, that's the same as multiplying by 2. I think there's an error on the hard copy answer key, so it's correct here. And then the derivative of your inside function is negative 1, so you'll have to divide by that negative 1 here. Next 3 problems. On this one, you have to go up a degree to 101 and divide by 101. And then your inside function is 5t minus 2, and the derivative of that is 5, so with anti-differentiation, you divide by the derivative of your inside function. Number 5, since the derivative of this inside function is 2x, you have to FOIL this out before you anti-differentiate. You are not permitted to just divide by a derivative if the derivative is not a constant. Since this derivative has a variable in it, you may not simply undo the power rule and divide by 2x. That is a no-go. So when you FOIL this out, you get x to the 4th plus 6x squared plus 9, and then you anti-differentiate each term using the power rule. Number 6, basic power rule problem goes to x cubed over 3 plus x plus c. Next 3 problems. For number 7, you have to split this into two different terms. You get x plus 1 over x. You integrate the first term with the power rule and the second term as the natural log of the absolute value of x. Don't forget your plus c. Number 8, once again, you have to simplify this all out before you can integrate it. So you'll FOIL to get x to the 4th plus 2x squared plus 1, and then you'll divide each term by x. That gets you x cubed plus 2x plus 1 over x dx. And I just realized we didn't talk about this integral notation, so I'll do that in a minute. This integrates to x to the 4th plus 2x plus, x to the 4th plus x squared plus the natural log of x plus c. Just remember that when you see this notation here, it means the integral, and then this is the width of each little rectangle. So you learned this in the definition of the integral day. So when you see this symbol, that just means find the general antiderivative. For number 9, 1 over x squared plus 1, you just have to memorize this one. The antiderivative of this is arctan, because arctan differentiates to 1 over x squared plus 1. So you need to really, the two that you need to know cold are the 1 over x squared plus 1 goes to arctan, and 1 over the square root of 1 minus x squared goes to arcsine. Those come up a lot. All right, next 3. Basic power rule for number 10, you just go to 5x squared over 2 plus 7x plus c. For the next one, it might be easier to write that second term as negative 2x to the negative 2. First term, you really just have 3 times 1 over x. So you have 3 times the antiderivative of 1 over x, which is the natural log of the absolute value of x. Then we take negative 2, and the x to the negative 2 goes up a degree to x to the negative 1, and you divide by a new degree. And he didn't simplify this out, but you could just as easily have said 3 times the natural log of the absolute value of x plus 2 over x plus c. You can leave it like this for the free response, but multiple choice, they would most likely clean it up without the negative exponents. Number 12, you're going up a degree and dividing by the new degree. For each of the first two, here when you have x to the 1/2, it goes up to the 3/2, and when you divide by 3/2, it goes to 2/3, so your denominator simplifies out to 15, which you could have left it 3 times 5 if you want, that's fine. And then here, negative 2 over x goes to negative 2 times the natural log of the absolute value of x plus c. And then we finish the page with the last 3 problems. We've seen number 13 before. You have to memorize that 1 over cosine squared is secant squared, and that the integral or antiderivative of that is tangent. Then don't forget that when you have an exponential with a base other than e, instead of multiplying by the natural log of the base like you do when you differentiate, you're going to divide by the natural log of the base. So this one goes to 2 to the x over the natural log of 2 plus c. And then finally, e to the x goes to itself, 5 goes to 5x, and then you add the plus c.